Level 4, number 3. Okay, so I'm going to draw this picture. We have this long string, and what's going to happen, this rock or this mass on the string is going to swing down in an arc, and it's going to get down to here. So the second position will be here when it swings down. That's called position Q. But there happens to be a little peg right about here. And what's going to happen is that peg is going to catch the string, right? So now the string is going to start to bend around the peg. And I'm just going to draw this. It's going to swing up like this, right? And it's going to go around and swing all the way up to the top until it swings up like this. And that is the position that we're talking about, position S, after it is caught and swung up around the peg. So we can erase these guys. So there's my position PS, sorry. So this is called P for peg, which is not part of the actual question. Let's put a little P there for the peg. And then position S is up above here. So we'll put that in position S. All right. Now, if you think about this question, it looks complicated, but really what we have is something that's moving with speed, so it has kinetic energy, and it has different heights, gravitational energy. And it's MGH, gravitational energy, because we're talking about something near the surface of the Earth. There are no spaceships and orbits and things or things like that. So it's simple equations if we can just figure out the relationships. Okay. So to get you started, I'm just going to help you. What you have are three different positions. You have position 1, or let's call it O for original position, right? So the energy total at position O has to be the same as the energy total at position Q. Now what's going to change, of course, is you're going to have no EK at the top. Here it's just EG because you're not moving yet, right? But down below here it turns into EK, so you get a lot of speed but very little. Well, if you call that your zero, your lowest point, you have no gravitational energy. But also you can equate this to the energy at position S as well. That says total. No, it doesn't. Let's fix that. E total position S. Now, the difference at position S is that the object hasn't stopped. That's going to keep swinging around the peg, right? So here you have EK and EG at this position S because you're going this way and you're swinging around the peg. And we know you have to have some speed left over because you're not as high as you were originally. So remember, if you don't go as high as you were originally, then some of your energy must remain as speed because it hasn't all turned back into height. So now I want you just to use the numbers in the question to figure out all the different heights. Now remember, when you do MGH, always measure from the ground up. Don't measure from a spot here and see how far down you go, because that represents a negative MGH or a loss. So try to express all of your H's in terms of ground up. So, or when I say ground, I mean your lowest level. So all the H's will be relative to position Q, relative to the bottom, okay? So what you need to figure out then is, what is this initial height here, HO? The height at Q is obviously 0, and then what's this height here at S? And you can do that because you have some numbers there. You know the total length of the string. You know how far the peg is away from the top, so you can figure out those H's. And then you can use these equations. Now you might start with this one, and then you might use this one after, or you might choose to use this one and this one, right? They're all equal, so you can have E total O equals E total Q, you can have E total Q equals E total S, or you can even have E total O equals E total S